Most people imagine artificial intelligence as an invisible magic trick, a web of software operating seamlessly in the cloud. But those algorithms don't live in the ether. They require vast, energy-hungry warehouses of physical hardware to function. To pay for this infrastructure, Meta cut 10% of its global workforce, reallocating that capital directly toward AI development. Tesla committed $25 billion in capital expenditures, specifically to build massive new training clusters. Even SpaceX has locked in a partnership built around a supercomputer packing the equivalent of 1 million H100 GPUs. This is not a battle of code. It is a brutal, expensive race for heavy hardware. And despite their massive resources, these trillion-dollar companies share a glaring vulnerability. They are all standing in line to buy from the exact same supplier. That supplier is Nvidia, and its absolute control over these specialized chips pushed its market capitalization past $5 trillion. That valuation places the chipmaker ahead of historical giants like Alphabet and Apple, making it the single most valuable listed company on Earth. The giants building the future of intelligence find themselves in a paradox. They are spending billions on a future that only one other company can actually build. So why is the broader tech industry completely dependent on this specific hardware architecture? Traditional computer processors, known as CPUs, solve problems sequentially. They take on one calculation at a time. Training an artificial intelligence model requires parallel processing, calculating millions of simple math problems at the exact same moment. This computing method was originally developed and perfected in the 1990s for rendering the fast-moving pixels of video game graphics. The mathematical engine originally built to draw virtual worlds turned out uniquely capable of processing the vast amounts of real-world data required for AI. Today, Nvidia's state-of-the-art Blackwell and B300 chips serve as the foundation for the next generation of artificial intelligence systems. Entire data centers are being constructed strictly to house dense rows of these units, acting as the physical brains of the modern economy. This chart illustrates enterprise AI adoption rates, showing a steep trajectory where 75% of global IT organizations are expected to integrate this technology into their operations by 2026. As these chips come online, the sheer availability of raw computing power is pulling resources directly away from manual coding. Looking at this graph of task allocation shifts, we can see a direct inverse relationship. Manual coding tasks collapse, while AI-supervised oversight rapidly becomes the new industry standard. By supplying the hardware that runs automated code generators and intelligent support bots, Nvidia provides the tools for companies to systematically replace routine labor with high-speed computation. We have moved past the speculative, software-only phase of artificial intelligence and firmly into a massive infrastructure build-out. Just as the heavy industries of the 20th century relied on the continuous production of steel, the digital economy now depends strictly on the physical output of Nvidia's fabrication partners. The rate of technological advancement and the economic disruption that follows is now tethered directly to Nvidia's shipping schedule. For companies like Tesla and Meta, securing these chips is not a side project. Their survival depends on paying the toll at a $5 trillion gate. Pacing slows slightly. Nvidia's fabrication cycle now functions as the primary regulator for the global transition into an AI-first economy, dictating the pace at which the future is delivered.